This is known as H2 practical planning. All right. You've selected this, there must be some reason. All right. And first thing first, I would like to congratulate you. Why? Because if you ask me, all right, as a chemist, a professional chemist myself, I think this is the toughest. Do you agree with me? All your planning at this level, whichever sciences, I think is really tough. Chemistry is one of the toughest. All right. The theory is tough. Practical is worse. Why? Because it's not testing you on just your theoretical concepts, your keywords, your calculations. It needs you to be very, very, very playful, very meticulous, very, very cunning and scheming. I would like to use the word. Who will do very well for practical planning? I let you know. There are two groups of people. I think they'll do damn well for it. First is called the scammers. You know scammers? Unfortunately, some of you probably know 2 months ago, I was being scammed by international scam group. So I lost some money. Again, the police is investigating. I'm helping them, right? Not about money, I want to catch them, but it's not very possible. Put it that way. Okay, I was scammed, right? The scammers will be damn good in planning. So again, I'm not training you to be scammers, but we have to think like them, okay? In order to do planning one way or another. Now, the other group, I think they will do very, very well in this. They will never be your lecturers and your tutors in your school. I'm not the best person also, if you ask me. All right, even the professors, some of my friends, they are prof, all right, or assistant prof in university. You ask them planning, they'll say, okay, I'll get back to you. They probably even tell you, you're going to ask someone else. They don't want to do it because it's hard. The person that's very good at this is the one that is in charge of the lab. It's called a lab technician. Why? Because they prepare all your solutions day in, day out, every day. Sodium hydroxide is prepared freshly every few days, if not every week, for your information, for its own reason. Okay, and that is itself is a question in exam. Right, move on. I'm not sure whether you know why sodium hydroxide has to be prepared freshly every few days. You cannot leave it there for a few months. Anyone would like to share? Mind in or chat in as early as now. I haven't even gone into the materials. Anyway, wrong, never mind. Just play out. In exam, you're not going to leave blank, right? You're going to write something. Write some rubbish also. Right. All right. What do you think? Anyone? Why sodium hydroxide solution has been freshly prepared every few days? All right. You can leave it for a month and then I use it later. Do you know why? Okay. Later we'll go through that, but I can let you know first. Sodium hydroxide, you use it for what? Usually one, if not two, so-called users. Sodium hydroxide, you use it for volumetric analysis. Yes, the titrant. Yes, right. You may not really agree. Right? There's a reason why you have a camera on. Okay. Form Na2O. Not really near them, but it's a good choice. Is it a good attempt? What else? You see, all this we learn already. This is what we call practical planning. Right. And then what? And where else we use sodium hydroxide besides volumetric analysis? We use it for your QA. Remember your test for cations, even test for nitric anions. So when your sodium hydroxide, right, is exposed to the air for too long, you know what happened? Let me bring you back to Sec 3, which also you have learned it in GA2. Sodium hydroxide is an alkaline, it's a base. It will react with something in the air, and therefore the sodium hydroxide in terms of number of moles in the sodium hydroxide solution would have decreased, i.e. your results not that accurate, especially volumetric analysis. That's the one. Make sense? All right. Anyone? Someone want to type something? React with what in the air? Yes, come on. Where is it? Carbon dioxide, sealing, very good. All right. So this is a 1 mark question in exam. You see? All right. So later there is one of the questions somewhere, I think lying either today or tomorrow we've been doing that. Okay. And that's how I want to welcome everyone to this workshop, all right, known as a practical planning workshop. All right. Now, I think most of us, if not, why don't I just say most of you, students-wise, I think usually most of you can diligently follow the procedures to obtain the necessary data in your practical, right? Your paper 4, your practical exam. I think that's not an issue. Sec 3, Sec 4, all the way you can get most of the result. The volume and all this, I think not an issue. Can follow procedure, not an issue. Singapore students all can, Singaporeans all can. I always say, else we went to jail, all right? But most students do not know the rationale behind the procedural steps, the steps, right? They ask you to do a step. You just follow, but you never ever think of why I'm doing that steps. To be honest, if since J1 until now or Sec 3 until now, if you have been slowing down and look at all your practical so-called assessments, your practices, and you run through all the procedure that you have been doing, and you actually ask yourself those questions, and you're going to ask someone about why you need to do these steps, you don't have to be here. I don't think you can master practical planning. I can't, but I think you will be passing practical planning quite well. You're quite comfortable to do it. You say, okay, give me, let me play. Let's try it out. All right, that's what I'm saying. So it's the procedure steps. I think that we are struggling. We don't know the rationale. Also, we don't know what? We don't know what is the quantity to be used. Correct? Because if it's a practical, then they will give you all the things to add. How much, what's the mass, what is the volume, what's the concentration to tell you. But now different. Planning, you have to start from scratch. All right, start from scratch. As well as the apparatus chosen. They won't tell you what to use. They say the apparatus is there, choose it. Or in fact, they say you can use anything that is found in your school lab usually. All right. Then suddenly we give you the ocean, you don't know what fish to catch. That's the problem. All right. So think about it. Now, so this is where it comes to the fact that we are at a loss of how to even start off with a planning question. All right, in your practical. So practical, once again, I take the chance, all right, to do a very quick few minutes recap. I'm going to mark on because the student is here on site. All right. So later, then let you see my face again. Okay. So everyone, I suppose you still can see me. All right. So here we go. I'm going to start. First of all, there are 4 sets of material. Right? Everyone should have it, called 10 years analysis, 1 piece of planning, main components, possible planning, and then this is a very thick one called topical planning questions, which I just choose a few topic, the high hit rate topic, and then we have a quick discussion, right? And see what we're going to do about it. Now, first of all, I want you to appreciate that very quickly that in your practical, right? So your P4, paper 4, which is your practical, right? Let me write it down. All right, a quick one, a practical. In case you still don't know, it's 20% of your whole so-called syllabus, exam-wise. You got 4 papers, P1, P2, P3, P4. This is 20%, which means it is a 50 marks total out of, if I'm not wrong, 240 marks. Let's make up 20%. All right. So all your paper add together is 240 marks. All right. This is 55 marks. Planning itself, all right, will have some percentage. Anyone know what is the planning itself percentage? Anyone know planning was a percentage? No? All right, planning itself, all right, you go to SEAB, I can show you during break later, it's about 5%. All right, it's 5% itself out of the 20%. Right? So it is very, very big. And the thing is what? Planning, if you look at it, a lot of times, it will come out as a planning question on its own. So it's planning times 1. But I would like to let you know that, again, so we are usually, it's 5% here. All right, and then we have what we call all the one that you follow the procedure, right? The experimental questions, right? The experimental questions. So you follow the procedure, you collect the results, tabulate the results, you draw a graph, and then you answer the mode calculation question, you link it to theory, they ask you some theory question, right? So this usually is 15%. Yeah, so add up together is 20%, not practical, right? So add up together is 20%. Now, in case you are wondering, all right, or you were thinking all this while, is like, okay, planning question is the 5%. All right, so there are some marks there. If I don't know how to do, I just skip it, then it will not affect the rest. I just let you know, in case you have not seen enough question or you're not very observant, is that this planning, it may not be just here. It could be part of the first 2 or 3 questions here. I don't know where they ask you a 2 mark or 3 marks, which is part of the planning question. Am I okay? All right, so it's not always the last question called planning. The planning could be here. So maybe here is only 3%. Right, a question worth certain marks is about 3%. Then there's a 2% of planning over here. I.e. the question 1, question 2, the first few, whereby you do practical, is 17%, so on and so forth. Okay, so I just let you know. So planning is inevitable. It cannot escape from it. All right, like it or not. So that's the first thing I would like you to kind of appreciate, all right, so that you don't get shocked in your life. Okay, so again, those earlier questions, you could have planning in it, but the marks are usually lower. All right, 2 marks, 3 marks, 2 marks, 3 marks. 1 mark. All right, welcome everyone is here, right? So Renee, Emily, all right, camera all up, okay? Now, so what? So in this workshop, all right, I don't think I need to so-called repeat the notes. Everyone have a very thick set of notes, yes? The problem with your thick set of practical notes, you know what? Your school is every school, the notes is about the same one, because I copy you copy here, we share here, we share here, it's all about the same. So don't bother getting another notes. Use your own school one. And the school notes is comprehensive enough. It is so comprehensive, actually, that actually stop you from revising it, isn't it? Why? Because a lot of you comment that the lecturer, all right, only just, maybe only discuss 1 or 2, or didn't even discuss it. Okay, just go and memorize it. Technically, yes, you're supposed to go and run through them, but it's not called memorize. It's supposed to understand it. All right. So again, the notes in your school are very well researched, are very comprehensive. You don't have to find another set of notes. Everything is there. But the thing is, the question doesn't come that way and then let you repeat it out. You can't. So your procedure need to change a bit. The calculation need to change a bit. Everything will change a bit. So you're supposed to learn from there. All right. So my job right now is to share with you a framework that I believe, all right, will help us in the planning. Okay, will help us in our planning. So when did I learn all this? I can share with you, I didn't learn it from a lecturer. I don't learn it from a professor. I learned it from, just now I told you, my lab tech, when I was in Polytechnic. Okay, I was always, how come they know how to propose a solution? Then we kepo, right? Everyone asks, hey, how are we going to disturb them? Then you realize they always do something called flow chart. They will do their pre-calculation, their reasoning, before they even start to prepare, because they cannot make mistake on, right? Because they are employee, right? They will be sacked, right? If they keep wasting, like, hey, how come every time you ask me buy sodium hydroxide, right? The principal will ask or someone will ask, right? So they're very, very careful in the calculation. Okay, so here we go. My job is to give you a framework. So let me make sure that this is recorded. All right, there are some students that couldn't join us today. By the way, A-level has started, in case you don't know. A-level has started for some so-called I don't know what I call it, hybrid subjects or the smaller subjects, computing. Right, some student computing, they couldn't join us, so they will be listening to the recording. Right, they couldn't be here. I think starting into 1 day now, 2 days time. Right, they all started. Okay, here we go. First thing first, I just want to let you know this is this is called the 10-year analysis. All right, a quick one. This was what I copied from SEAB, their examination board. Right, straight to the point, paper 4 assessment. Right, based on Singapore Examination Assessment Board website. Okay, so here we go. The paper is designed, right, according to the one that sets them, to assess your competency in practical skill, which can realistically be accessed within the context of a formal practical assessment. Now, nothing much there, right? I just copy wholesome, okay? Now, candidates must be able to do this in all planning questions. That's where we become interested. Do you know how to define the question or the problem immediately, which is actually our first step later you'll see, using what you have learned, your appropriate knowledge and understanding. So that's the first thing, right? So your content must be good, your theory. To do practical theory first must be quite okay. Second is it must be a logical account of the experimental procedure to be followed, obviously, the steps, right? And third is how the data should be used in order to reach a conclusion, right? So this is where your analysis of the data, right? How you play with the data. And last but not least, they love to ask you what are the precautions, the risks, right, of the experiment, and describe ways to prevent it, right? So that it's taken to a minimum, the risk to a minimum, right? So this is what SCAB want me to tell you, not SA1. This is what your lecturers, everyone will follow. Me, I have to follow also, right, in the practical. Now, this is the one I will just told you in case nobody tell you before. Again, from SCAB, one or more of the questions may incorporate some assessment of skill P, meaning planning, set in the context of the syllabus content. So don't worry, it is definitely part of what you've learned. It can't be something in university or poly that you never learned. It is something you learned before. Where it require you to apply and integrate knowledge and understanding from different sections of the syllabus. So the key thing is you're going to cross topic like nobody business in planning. Okay, and it also requires you, right, to treat the data, right, experimental data. So sometimes they give you the data, then they ask you to do plan out of the data, and then obviously draw a relevant conclusion and obviously give them a proposed plan. All right, so I just told you what SCAB wants me to tell you. Okay, so once again, planning could be everywhere. I call it 10-year analysis, but it's not 10 years because your syllabus is very, very in infant stage. It's only 5 years old. You're the 6 years. All right. So it all started 9729 in 2017. All right. Planning used to be in paper 2, I think, and the marks are exotic. So nowadays it has become different. It has been here. Right. So I'll just share a view from 2017 onwards. If you like to know the previous another 5 years, let me know. All right. I'll see whether I can consolidate them accordingly. Okay. Ladies and gentlemen, in the first year of your syllabus, 2017, kinetics were tested. Keyword wise, it was 14 marks. What was the 14 marks about? Right? A quick one. Okay, just have a good look. The question asks you to determine the effect of the temperature T, right, on the rate of decomposition of hydrogen peroxide using catalase, this enzyme. Right, so that's something to do. And along the way, they ask you to draw the graph of ln K prime versus 1 over T, which later on they ask you to determine the values of EA. What is EA? Your activation energy. What is A? A is the Arrhenius equation, or rather the Arrhenius constant. All right, and this one by using the Arrhenius equation and the graph. All right, in case you don't know what Arrhenius equation is, linked is your rate constant equation, right? Rate constant equal to this. Those I've taught you is in my class. I've been sharing with you a lot on this. They say this is not in syllabus. Rubbish. You better know before you go to the exam. All papers, paper 1 to paper 4. All right. Okay, so this is a small K. My handwriting not the best today. All right. So you realize the terms are here, okay? So basically you're doing graphical method, right, to solve all this, which they will actually ask you to plot the graph first. So A is here, okay, see? So this is our constant. All right, so something along that line. Just an introduction, right? We haven't even started. So that's the year of the kinetics. And 2018, it came to the energetics year. So every year, usually one thing is that we predict is what? It won't be the same topic. That is something we have been seeing for the past 10 to 15 years, okay, all the way to the old syllabus. Usually, okay? So, but cannot blame anyone, right? So your school is doing the kind of predictions anyway. So energetics, they ask you to determine the maximum temperature change, right, graphically, for the reaction between copper, sulfate, and zinc. So this is metal displacement reaction. So you put zinc, you displace copper, right, and form new solution. You use temperature. I think it's exothermic. That's why it's called maximum, right? Then you'll be able to find the maximum. How? Very easy. They even tell you what to do. Plot the graph of T versus time. So you collect all the T at a certain time, all right? And then I believe the graph looks something like this, right? This one I think is quite easy. So basically, what kind of graph you do? I think it will be something like this, right? So somewhere you go up, and then somewhere you come down, and then there's a maximum. Yes, everyone? Energetics, this is very common, remember? Yes? So this is your maximum point. Okay? Something like this. And again, how many marks is it? 13. So if you take a calculator, 13 upon 55, I think it's about 5.3% to 5.5. So the 5% is plus minus. Nobody say you must be exact 5% to be tested. All right? Which is a lot. So all this, if your theory is strong, actually quite okay one. But theory is one thing. Need to be scheming. So later we try to learn like a scammer, right? See how scammer think. Kinetics, again, back here, right, is to collect sufficient data to allow a graph of volume of sodium thiosulfate against time to be drawn. There are a bit more information on top, which I never shared. Right, so again, this one is a smaller topic, a smaller question, it's only 8 marks. So the rest of the marks where it goes to question 2, the experimental question. So there are some high planning question hidden in all those experimental questions. Okay, so here we go. 2020, well, this was the year. Either you get full marks or you get 0. Really, that is the year. Never ever for, I don't know how long, at least for 12 years, I've been writing TYS, I think more than 12 years for A-levels, I think, yeah. So never ever. So this year, some of my students that, this was the first paper, right? Some of my students, they're very consistent with their so-called studies, right? Okay, in my tuition classes. So organic, we finished like not too far ago, a few months ago. So they remember everything. So they went in, they were damn lucky. They say, I think I can get a lot of points because they can write from the start to the end. Some people never realize organic chem can come out. You know what? You go in, what to do? Nothing to do, zero. You leave blank. You can't even start. Okay, so be careful, everyone. I want to take note, you to take note. Organic chemistry can come out. It already came out in the new syllabus already. Plan the procedure for the preparation for what? 10.0 gram of pure and dry. There are two keywords. It must be pure and it must be dry. Later, we'll be talking about this. Nitrobenzene from your benzene. Okay, this is nitrobenzene from benzene. All right, so where do you learn all this? All right. Okay, you learn it from, I think, Avins, right? It can be easy, right? How to do this? Can someone, like, test your organic chem? Benzene, nitrobenzene, how to go there? Right? Reaction scheme. A quick one. Can you see? Reaction scheme can't even do right. Zero. There's nothing you write. What you want to write? There's nothing you write. What can we do with a benzene ring? So we are in the topic called aromatics, Avins, correct? So Avins, there's a few things you can do, right? Avins it's pretty quite reactive, yet not very reactive, right? You can do what? Con HNO3, con H2S, so forth, right? Don't direct message to all, right? You can grow your nitrobenzene there, right? So you can use your con HNO3 and your con nitration mixture, right? Con H2S, so forth, right? So on and so forth, and then heat under reflux, right? With reflux and so on and so forth, and then you'll get your nitrobenzene. All right, so all these were kind of covered in the notes, and then along the way, you must see what you need to do to make it pure and make it dry. Okay? How many marks? Ooh, I think this is a 5 marks question. 5%, I mean, not 5 marks. Okay? If you ask me a similar question, what will come out? Anyhow, okay? All right, because I saw this immediately, I think of this. Currently, you want to make this, right? I think there's one more that is more recent towards me, which is what I'm more familiar in terms of reaction-wise. Why not this one? Agree? I think this one more fun. Remember this one? Remember this one? Because to get phenylamine out, first you have to add thene and excess HCl. That one, remember the excess thene, so on and so forth? Remember the step or not, my friend? You have to add sodium hydroxide here to liberate it out. Remember not the so-called liberate the phenylamine. Make sense? I'm helping you, my friends. Right? Just finish prelim, right? All this should be a little bit still there, I hope. Okay? So why not? So there is understanding. Can you see? So why not 30 marks to do this anytime? Because not easy, a lot of steps. Okay, so think about it. All right, so flip a bit on the organic, all right, and then see which one got possible. All right, again, you never know. Not easy, all right. In case you're saying, Mr. Chua, why don't you have this workshop long time ago or teach a weekly class? Weekly class, where got time? I just finished my syllabus. Why am I J2 student? Your school finished 6 months ago. I just finished. I don't know how they can go so fast. I never know. I can't. My speed is damn fast, right? Every lesson I overrun, you realize. I still cannot finish. Let them go. It's okay. See who's the final winner. Okay, doesn't matter. All right. So once again, I want to run this in J1, but you see, J1 you run this, hope people come now. Nobody come on. Is it planning? I am. It's a waste time. Right. But if I teach it in J1, I'm very sure, right? Students that attend it and they're reminded what to do in school, I'm very sure all the way to J2 they're planning has no problem. Right. Not to say score full marks. Maybe 12 marks can get 8 marks, 9 marks. It's very good. Right? 12 marks can get 8 or 9. It's them. Most people get 0 or 1. Right. Okay, can everyone? So here we go. Along the way, you do a basic mole calculation because 10 gram. Right. So a lot of assumptions there. You take a look. Right. Safety and precaution. Right. Organic, you know what are the safety and precaution. Right. Most of them, they are toxic. Yes. So if it's vapor, then you have to do it in a film mood, so on and so forth. Again, this we'll see in the note. Can everyone? All right. So now I'm giving you some teaser to know what is coming up. Yes. So in exam, you're expecting the same thing as you read the question. All right. So visualize a bit. Last year, we were waiting for this for the longest time. Because this one, all schools will do this experiment, right? Or will do this planning, and it kept on to come out. Came out last year. So based on what I just mentioned, the chance a bit lower, but you just never know, right? Plus, this is very easy, so prepare yourself. What is it? It's to plan an experiment to determine the value of X in sodium carbonate. So this is the one, you want to find X. And they force you, they say cannot use other experiment, just by gravimetry, right? So i.e. by weighing it. The mass of residue left. So this is 9 marks, not a lot, must say. So some of the marks, other question. Excuse me. Okay, so that's how we start the whole workshop, right? As a teaser. So at least you know what is the A-level standard. This is a standard for planning. Okay, so at least for the last 5 years within your syllabus. All right, so without further ado, we're going to enter here, which is the main components of a planning question. And this is where I teach you the framework, okay? Which I think you will not properly train because, again, sometimes I cannot blame your lecturer because I have a lot of lecturers in different schools. Only 2 schools, I don't know anyone there. Most of you, I see, I think I have a friend that is in your school teaching chemistry, by the way. A lot of them are my classmates at university and poly.